Hey there, Mr. Weaver here, and this is Geometry Lesson 3, the Pythagorean Theorem. After this lesson, you need to be able to find the measures of the sides of a right triangle using the Pythagorean Theorem and square roots. Let's learn right triangles. A right triangle is a triangle with one right angle. The legs are the sides that form the right angle. So here we can see down here in the corner our little square symbol for the right angle. The legs are the two sides that together make that right angle. The hypotenuse is the side that's opposite of the right angle. So if here's your right angle, the hypotenuse is the side that's opposite of it. It's the longest side of the triangle. The Pythagorean theorem describes the relationship between the lengths of the legs and the length of the hypotenuse for any right triangle. But the key here is it has to be a right triangle. It doesn't work for any other kinds of triangles. So what the Pythagorean theorem says that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That's a lot of words. Essentially what it means is if you were to draw a square on the two legs, so this square, and draw a square on this leg, adding those two squares together, their area would be the same as if you had a square on the hypotenuse. Now, we don't necessarily have to draw it each time. What we're going to see instead is saying the A square, so the square on the A side, plus the square on the B side is equal to the square of the C side, and C is your hypotenuse. This shows how to find the missing length in the right triangle shown using the following steps. So again, the Pythagorean theorem is A squared plus B squared equals C squared. So if we were to take the square for 21 to the second power, 21 times 21 is 441. So this area of that square on that side is 441. If I do the same thing on my other leg, down here, the square, 20 times 20 is 400. So 20 to the second power, 400. Now I'm going to combine those two things together, and I get 841. That tells me that the square over here is 841. Now, to figure out the side length, we're going to take the square root of that number. Remember, the opposite of an exponent to the second power is a square root. So if I take the square root of that number, I will get the side length. So the square root of 841 is 29, meaning that this side is 29, so C is 29. Now, with these, because we're talking about the side length and the distance, it can't be negative. So even though a square root really has a positive and a negative answer, we're only going to worry about the positive ones for the Pythagorean theorem. So my final answer would just be 29, since that's my positive square root. Example 1. Find the hypotenuse. A ladder is leaning against a building as shown in the figure. What is the length of the ladder? So here it's shown you know the lengths of the legs. We have our right angle here, which means our legs are the two that form that right angle. So if I know the legs, those are A and B. I'm going to plug in those values, and it doesn't really matter which is which. So 12 to the second power would make my square off of that leg. 16 to the second power would make my square off of that leg. Multiplying them out, 12 times 12 is 144. 16 times 16 is 256. Add them together, we get 400. Now, to find the length of the side, I have to take the square root of that. The square root of 400 is positive or negative 20. And again, since we're dealing with distance, we're only going to use the positive version. So the ladder must be 20 feet long. Check your understanding. Read through the situation and figure out the value of x if this is a right triangle. Pause the video now and complete the check. Check your answer. You should have said that the rope is 17 feet long. To get that square down here, 8 times 8 is 64. Square on the side over here, 15 times 15 is 225. Added together, that square over here must be 289. Then I have to take the square root of that in order to get my side length. So the square root of 289, positive or negative 17. Only take the positive, so positive 17 is our answer. So the length of that side of the triangle must be 17. Example 2. Find the hypotenuse in 3 dimensions. A 12-foot flagpole is placed in the center of a square area. To stabilize the pole, a wire will stretch from the top of the pole to each corner of the square. The flagpole is 7 feet from each corner of the square. What is the length of each wire? Round to the nearest tenth. So here the legs are represented by segments AB down here and AC, where that's the height of the flagpole. The hypotenuse would be over here with BC. Now, this doesn't look like a right triangle the way the picture is drawn, but this is 3D. We can see down here there is a right angle symbol telling us we are dealing with a right triangle. Remember, this only works for right triangles. So let's use the Pythagorean theorem to find the length of the wire. AB is 7. It's 7 feet from each corner. So we're going to do 7 to the second power. AC, the height of the flagpole, is 12. So 12 to the second power. We have 49 plus 144. Adding those together, we have 193. Now to find the side length, I need to take the square root. And the square root of 193 is 13.9. We're going to only deal with the positive, and it's said to round to the nearest tenth. So I would need to make sure that I round to one place after the decimal. This is our first instance where the square root did not come out nicely. It happens a lot with the Pythagorean theorem. The number inside is not a perfect square. So when we come up with a decimal, and you probably noticed when you did on your calculator, it wasn't just 13.9 and it was done. It kept going on forever and ever. When we're dealing with the Pythagorean theorem and the square roots that are not perfect, they're going to produce side lengths that are called irrational numbers. So IRRATIONAL, irrational. That just means that the number goes on forever and ever, and you can't make a fraction out of it, essentially. So in Pythagorean theorem, we're going to deal with a lot of irrational numbers, which are not perfect square roots. If it does come out nicely, like we saw in the last example, those are called rational numbers, where it doesn't have that IR in front of it. Anyway, back with our Pythagorean theorem, we found that our wire would be about 13.9 feet. Check your understanding, read through the situation, and find the missing side length. Round your answer to the nearest tenth. Pause the video now and complete the check. Check your answer. You should have said that the edge of the cone from the top to the bottom is 42.4 feet. We would do 34 squared, which is 1156, plus 25 squared, which is 625. Added together, we get 1,781. Then we want to go to the side length, so we need to take the square root of that, which we get plus or minus 42.2. Again, it doesn't come out perfectly. We had to round it off. So this number here, the square root of 1,781, would be an irrational number, since it did not come out perfectly. Example 3. Find missing leg lengths. A plane takes off from an airport and travels 13 miles on its path. If the plane is 12 miles from its takeoff point horizontally, what is its height? So in the previous few examples, we have been finding the missing hypotenuse, that longest side length. This time, though, we are given the hypotenuse. That's how far the plane has traveled. It has went 13 miles and it's going in that upward direction. So we want to know how high is the plane above the ground. We're given two side lengths, and we can see our right triangle here. This time we are missing a leg. So let's look at what we need to do if we need to find a missing leg. We're going to still use the Pythagorean theorem, but this time we're going to put in our hypotenuse and one leg and then solve for what's missing. So I know that one of my legs was 12. This time I know my hypotenuse is 13. So I'm going to plug that in for C. Hypotenuse is C. When I multiply them out, 12 times 12 is 144. 13 times 13 is 169. Now, in the previous examples, we added those two numbers together to get the area on the side of the hypotenuse. To find the area on the side of a leg, we're going to subtract. So if I subtract 144 from both sides, I end up with 25. So to find a leg, you're going to subtract. Then, since we really just found the area of the square on the side, we still have to take the square root like we did before. So the square root of 25 is positive or negative 5. And just like before, since we're dealing with distance, or here it's the height, it would just be positive 5. So the plane must be 5 miles above the ground. Check your understanding. Read through the situation and use the diagram to determine the height of the kite. Round to the nearest tenth. Pause the video now and complete the check. Check your answer. You should have said the kite is 35.7 feet in the air. If we're multiplying out, 50 squared is 2,500. 35 squared is 1,225, so that was 35 squared. Because I want to know the length, so maybe this is B, of a leg, I need to subtract. So 2,500 minus 1,225, that tells me that this over here, the area of that square is 1,275. Then, taking the square root of it, we get 35.7. Which makes sense. If this was 1225, then 1275 would barely be more. So our number is a little bit more than 35. Example 4. Find missing leg lengths in 3 dimensions. Gravel used for construction purposes is piled in the approximate shape of a cone. The distance from the top of the cone to the edge is about 17 feet, and the height is about 8 feet. What is the approximate radius of the cone? Round to the nearest tenth if necessary. So I need to find my missing radius. So the radius, remember, was the distance from the center to the edge. And we can see here that we have a right angle, which means we can use the Pythagorean theorem. So let's use the Pythagorean theorem. We're given one leg is 8, so 8 squared, plus b squared is going to equal 17 squared. Now we can start multiplying out. 8 times 8 is 64, 17 times 17, 289. Since we're solving for a leg, we can subtract from both sides. So subtracting 64 from both sides would give us 225. That means that b squared is 225. To get b, though, I still need to take the square root. So the square root of 225 is 15. So I know that the length here, the radius of this cone, is about 15. And again, since length can't be negative, the radius must be positive 15 feet. Check your understanding. Use the diagram and read through the situation to determine the height of the roof. Round to the nearest tenth if needed. Pause the video now and complete the check. Check your answer. You should have found that the height was 21.8 feet. Again, we can see here, even though it doesn't look like a right triangle, we can see that little square in the corner. Knowing that it's a right triangle, we can use the Pythagorean theorem. So 50 squared minus 45 squared would give us x squared, and then taking the square root of that would give us 21.8.